Okay, so we are still displaying and summarizing quantitative data, just a little bit different. So another simple graphical display for fairly small data sets would be a stem plot, also called a stem and leaf plot. So I feel like when you're younger, you usually hear it as a stem and leaf plot. Um, Here we'll be calling them more stem plots. Okay, so stem plots do pretty much the same thing that your dot plots do. They give us a real quick picture of what the shape of a distribution would be. Okay, they're also going to include the actual numerical values in the graph, which is interesting, and that dot plots don't do. Okay, I've seldomly see questions that ask you to come up with a stem plot outside of when we do them right now. But you certainly do have to know how to read them, okay? But again, for showing shape, center, and spread, they pretty much do the same thing as dot plots, okay? They just maybe take a little bit longer to create. So let's go ahead and look at the steps in how to make a step plot. Okay, the first thing that we're going to do is we're going to separate each observation into a stem, all but the final digits, and a leaf, the final digits. So if I had the number 25, the stem would be the 2, the leaf would be the 5. If I had the number uh, 253, then the 25 would be the stem, the 3 would be the leaf. You'll see an example after this slide. We're going to write all stems from the smallest to the largest in a vertical column and draw a vertical line to the right of the column. You'll see what this looks like shortly. Just a little hint, I tend to order my numbers before I begin my stem plot. We're then going to write each leaf in the row to the right of its stem. So for 25, I would put the 2, and then to the right of it would appear the 5. Same thing with 253. 25, the stem to the left, to the right of the vertical line would be its leaf, and that would be the 3. We'll then arrange the leaves in increasing order out from the stem. So if I had to do 253 and 256, I would write 2, 5. Next to it would be, on the other side of the line would be the 3. Next to that would appear the 6. You also have to provide a key that explains in context what the stems and leaves represent. So let's take a look kind of at what these may look like. So here's 20 female AP students who were asked the question, how many pairs of shoes do you have? We're going to construct a stem plot. Okay, so again, what I would recommend doing, but you don't have to do it by any means, would be ordering them from least to greatest to start. Just makes the organization a little bit quicker when you actually have to, and then it tends to look a little neater and more organized. So here's the stems, okay? So the stems are all of the first digits, not the final digit. So you can have 3 numbers here if your numbers are in the thousands. You can have 2 if they're in the hundreds, okay? Here we're just looking at 10, so we'll just have 1 digit in our stems. Okay, here are the leaves to follow. Okay, so where we're representing, so we are representing 19, 13, 13, 13, 15, all appearing in your list of numbers, okay? Down here would be, here's 49, okay? Here's 31, 38, 34, 30. And for this very reason is why I say I tend to order my numbers first before I start a stem and leaf plot, because this would be unacceptable. You have to have them in order from least to greatest. This is going to do 2 things. Number 1, it's the proper way. And number 2, it also helps with describing shape, center, and spread, specifically that center, okay? So you could choose to first do it and then order them, okay? Or you can order your numbers first, and then you would kind of come up with this stem plot to begin, okay? And as your final step, you're going to want to represent, you're going to need a key to represent, okay? You don't have to choose this 49, okay? You could have done 1/3. 1 represents where it would represent the same thing, only down here would be 13 pairs of shoes as opposed to the 49. So you're free to pick any value for your key. Okay. There are times where you may want to do what they call split stems. Okay. So when data values are bunched up, we can get a better picture if they're kind of spread apart more. So what you do would be to split the stems. Okay. So if you had, let's see here. So here you don't really come up with that issue because you have kind of a big spread among these numbers, okay? But if you say would have had more numbers starting with 1 and more numbers starting with 2, and then not so many, with 3, and maybe a few more with 4, okay? It's not going to give you an accurate idea of what it looks like if you just stick to what we did here for the females. So what I like to look at is what's going on here with the males, okay? So you guys have this. If I was to create a stem plot with these numbers are much more closer together for the males than they were for the females, okay? So what I would recommend would be splitting them here, okay? So possibly the first, so if you had, 1, 2, so if you had like 1, 2, if you had like 1 to 4 here, and then like 5 to 9 here, if you had, and then here you would have 10 to 14, and here you would have 15 to 19. So it will give you a more, a better display, we should say, of the numbers if you split the stems. So splitting the stems for the men, you could see they were so close together that you'd almost have to split them. Otherwise, you would have like 2 rows. It wouldn't be much of a data display. Okay. So the next thing that we could do is we could put 2 distributions. So you can have a back-to-back stem plot as well. So a back-to-back stem plot would have your stems in the middle with your leaves on both sides. So now if I wanted to compare females to males, I'd have to also split my females, which I didn't have them split before. There wasn't the need to split them for the females, but if I'm going to do the back-to-back, I'd have to split them as well because it makes more sense to split the males. So filling in those would look like this. So now they're kind of red. Here's 1, 3. So 13, 13, 13, 15, 19, 22, 23. And then the flip side is on the males. Here's 4, here's 5, 5, 5. Here's 10, 10, 10. Here's 22, here's 35, here's 38, here's 38 on the female side. So it's easier to kind of compare the distributions when they're back to back like this. Okay, you would still need a key, and you would do the key the same as your single. Okay, so now what we can do with a back-to-back stem and leaf plot is we can make a comparison between two. So you guys were asked to write a few sentences about the distributions between the females and males number of shoes within the class. So some things I could say here would be both males and females have distributions that are skewed to the right. So you know, it's kind of up and down, but if you can visualize it horizontally, they both kind of have a tail end that would go to the right. Though the distribution for males is more heavily skewed, though. So there's your comparison. So you're going to say that both are skewed to the right, but it would appear that the males are much more heavily skewed. The midpoint for the males would be at 9 pairs, okay? That's much less than the midpoint for females, which was at 26 pairs. The number of shoes owned by females varies a lot more than it did for males. So the spread for women was 13 to 57, where the spread for men was 4 to 38. Okay, so it's much more variation within the females than the males. The male distribution has 3 likely outliers at 22, 35, and 38, okay, where it doesn't look like the females actually have any outliers. And that would be it with this video. Next video on histograms.